Hello everyone. So today let's solve the problem. This one, roads not only in Berland. So this was asked in the Codeforces bit around 25 for the division 2, right? So yep, this was asked in the Codeforces bit around 25 for the division 2, right? So now you can just go through the question. I'll just summarize the question so that it will be easier for us to solve the problem, right? So let's do one thing. Yeah, let me summarize the question here, right? So let's see what the question states here. Just give me a second here. Yeah. So we have been given n cities and exactly n minus 1 existing two-way roads. So we have been given here n cities and exactly n minus 1, exactly n minus 1 existing two-way roads, existing two-way roads, right? So this is fine. We have been given n cities and exactly n minus 1 existing two-way roads. So each day you may close one existing road and immediately build a new one, right? Each day you may close one existing road and immediately build a new one, right? So this is one thing. So what we need to find here, we have to find the minimal number of days and a plan. We have to find the minimal number of days and a plan, right? So just give me a second here. So again here, we have been given n cities and exactly n minus 1 existing two-way roads, right? Each day you may close one existing road and immediately build a new one. So what they have given here, each day you may close one existing road and immediately build new one and immediately build new one, right? So this is fine. Yeah, we have to find the minimal number of days, this one, minimal number of days and a plan, right? So we have to find a minimal number of days, and also this one, and a plan, right? So we have to find a minimum number of days and a plan, this one, plan, so that the final graph becomes connected, so that final graph becomes connected. So this is the main thing actually. Just keep this in mind, right? So what we need to do, we have to find the minimal number of days and a plan so that the final graph becomes connected here, right? So what we need to output, we need to output the number of days t. We need to output the number of days here, right? Number of days which is represented by the t, and t lines nothing but ij and t lines nothing but here ij u and v. So let me write it over here, ij u and v, and t lines ij u and v meaning close road, meaning close road, this one ij, and the build u to v actually, u to v, right? So we can just make use of the this one union find for this, right? So this is just this one hint actually. So let me read this question out loud. Just listen to this carefully. We have been given n cities and exactly n minus 1 existing two-way roads, right? Each day we may close one existing road and immediately build a new one, right? This one, immediately build the new one, right? So we have to find the minimal number of days and a plan so that the graph becomes connected, so that the graph becomes connected. So we have to output the number of days t. We have to output the number of days t, and t lines nothing but ij u and v, ij u v, meaning close road ij and build uv, right? So we have to use the disjoint set union. We have to build the disjoint set union, nothing but union find or the DSU. Basically, we have to make use of the union find or the DSU, right? Disjoint set union with the path compression, right? So this is just the approach. So now we have the idea on the question. Basically, let's move into the input output part. So we have here number of nodes, nothing but the n. The this one edge they have given here 1 2, right? So number of nodes is 2, we have been given, output is 0, meaning this one, the number of days t and the t lines ij meaning close road as well as the build is nothing but the 0 here. For this one, it is 1 followed by 3137, right? So this is fine. So we have the idea on the question as well as the example, this one input output part. Let's do one thing. Let's quickly discuss the this one approach, then followed by the complexities, and then let's write the code. Initially, let's discuss the approach. Let's discuss this one. Let's consider this first example itself for the approach, right? So here n we have been given 2. This is nothing but the n. and this one, what do we call edge we have been given? 1 2, right? 1 2, this is fine. So the approach that we'll be going with to solve this particular problem is DSU, or the union, find disjoint set union with a path compression, right? So this is fine. So what is the first point here? Let me tell you. Let's start with every vertex as its own this one DSU component. Let's start with every vertex, right? So let's start with every vertex that is present here. In this case, let's start with 1 and 2 basically, right? Let's start with 1 and 2, every vertex as its own DSU component, as its own DSU component. Let's move on with the second point here. So what is the second point here? For each existing edge, try to union its endpoints. For each existing edge, let's try to union its endpoints, right? For each, there is only one edge actually. For each existing edge, we have to try union its endpoints 1 and 2 here in this case, right? So if the endpoints are already in the same component, this edge is extra. If endpoints are already in the same component and this edge is extra basically. So this is nothing but a cycle edge and it can be removed later, right? So this is fine, I believe. For each existing edge, what we need to do, we have to union its endpoints, right? So we have to union its endpoints. So this is fine, right? So let's move on with the third, this one, third step here. So after processing all the edges, in our case, it's we have only one edge, right? After processing all the edges, basically this one edge. After processing all that, this example we are considering for the approach. So after processing all the edges, we have some number of DSU components. We have some number of DSU components. To connect K components, to connect K components, we need K minus 1 new edges. We need K minus 1 new edges. Each new edge can be created by reusing one previously detected extra edge. Again, just listen to this. Each new edge can be created by reusing one previously detected extra edge. Also remember, closing it and building a new connecting edge between this one, building a connecting edge between two different components is what I meant actually, right? So this is fine, I believe. Next, let's move on with the next step, or the final step here. For n equals to 2, we have considered this one, right? For n equals to 2, so we process edge 1 to 2. So this is the only edge we have. This I have already shown. We will process the edge from 1 to 2. We will process the edge 1 to 2. Union succeeds here. Union succeeds. They are in different components, right? So extra count here, extra count becomes 0. Extra count becomes 0 and number of components becomes 1. And number of components becomes 1, right? So this is already connected. So extra component becomes 0 and number of components is only 1 here, right? So output here becomes 0. So if they're already number of components is 1 and if they're already connected, output is 0 according to the criteria of the question. So this is 0. This is exactly why output for the this one example is 0 that I mentioned here, right? So this is 0. So the output that we got here is 0, which is equivalent to the output that they have mentioned for the example 1 within the question. So our approach works absolutely correct here, right? So as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So what will be the time complexity here? The time complexity would lead to big O of n. The time complexity would lead to big O of n. This is fine. So what would be the space complexity here? Basically, it will be big O of n. We can consider the inverse, this one, Ackermann, which is almost equivalent to big O of n itself. In this case, let's consider big O of n directly, right? So why it is big O of n? Processing n minus 1 edges with the DSU, with the disjoint set union, nothing but A is inverse Ackermann, as I've said, right? Processing n minus edge with n minus 1 edges with the DSU takes the time complexity, gives the time complexity big O of n, or big O of n, you can consider Ackermann of n, A of n, right? So this is fine, man. Yeah, what will be the space complexity? Space complexity would be big O of n as well. So why the space complexity here is big O of n? Because we will be going with a parent array and array storing some extra edges. We will be going with a parent array and array storing extra edges. Array storing extra edges, right? So this is fine. The time complexity and the space complexity for the code that we'll be writing in the future would be big O of n and big O of n respectively. Now, as we are completely familiar with the question, this one, what we call approach and the complexities part, we are good to write the code. Let's start writing the code, right? Let's do one thing. we'll be going with a different this one fast input output along with the different utilities, right? So let's import here, import input output package, as well as let's import this one util package as well, right? So this one will be util dot start. This is fine. The next one, let's go with uh, class. So this has to be small Simon. Yeah. Let me go with the main method. So within the main method, what we'll be doing. So first, let's go with the number of cities and this one number of extra cycles. That cycles. We can just say it here this way. Number of cities as well as the number of extra edges that we have found, right? So for that, we can just go with here, or we can initialize n as well as this one. Let me go with the extra count, the same thing that we had considered in the approach. Right, so now let's go with the DSU parent array. So let me go with static here. So this one int parent, so this is fine. Extra u as well as the extra v here. This is fine. Yep. Now let's find with a path compression, right? Path. Let's go with a find with a path compression, right? So this returns the representative or the root, or even we can call the parent of x. We know this. If you know the disjoint set union algorithm, right? So I'll just go with. So let me start this one in the new line, as this is the helper method, right? So I'll just go with int find. So this is fine. Let me go with a parameter x as usual. So this one, if parent of x equals x, then x is the root, right? Otherwise, we have to compress the path and return the root. So let me return here. Parent of x, if it is equivalent to x, then let's display x, or let's go with actually parent of x. This is fine. Which is equal to find of parent of x, right? So this one will be parent of yeah. Let me come out of this one entirely. Now let's do one thing. Let's go with the main method, right? So this one, let me delete this one. Yeah. Now let's go with uh, throws exception, or else we'll be getting the error, right? So this is fine, man. Yeah. Now let's go with the this one input output part, man. So let me paste this one actually. So this is purely related to the input output. So this is the fast input, nothing but the buffered reader, print writer, the fast output, and this one n is nothing but the we are just parsing this one basically integer, the first one n equals to 2, we have been given n equals to 7. So we have to pass, which is basically the integer, right? So this is fine, I believe. Next, let's move on with the main logic, man. So we have to read the number of nodes as well, right? So we have successfully read the number of nodes. Sorry, we have to initialize the DSU parent array as well, and this is one based indexing, right? So let me do one thing. Let me go with the parent here, and let me go with new int of n plus 1. So this is fine. And the next step would be we have to store the extra edges here. So we will store up to n minus 1, but allocate n for safety. So this one, let me go with extra u equals new int of n basically, right? So this is fine. Let's go with extra v. This is equals new int of this one. What do we call n as well? New int of n as well. Now what shall we do? Initially every node is its own parent, right? So we have to go with the separate components. So initially every node is its own component. Just remember this one. So let me go with the for loop here. I equals 1. We have to start with 1, right? I less than or equal to n. Let me increment this one. This is fine. For this one, let me do one thing. Let me go with parent of I equals I, as initially every node is its own parent, right? So this is fine. Yep. Now let me go with one more for loop, because we have exactly n minus 1 input lines, right? So that is describing the existing roads accordingly with the question in the input. So let's go with for loop here. This one int I equals 1, I less than n. Let me go with I plus plus, right? So within the for loop, what we will be doing. So let's read an edge line and split into the two integers. So I'll just go with the string here. V equals buffered reader dot read line. This is fine. Buffered reader dot read line. So this one dot split actually dot split. So this is fine, man. Yeah. Now let's go with U and V. Similar to this one. What do we call? Let me copy this one. Edge we have to consider, right? U and V. So let me paste this one itself. And edge basically it's the integer itself. So I'll just change the name here. Integer dot parseInt of this one instead of buffered reader. Let me buffered reader dot read line here. Let me go with p of 0, and for this let me go with p of 1 here. P of 1. Yeah, this is fine. Easy, easy peasy. So next, let's move on with the next step. So now let's find the DSU representatives, or let's find the DSU, this one parent for both the endpoints, right? So I'll just go with FU here. So this one will be find of U. Also, let me go with FV equals this one find of V. Find of V. So this is fine. Yeah, now let's do one thing. If they are already in the same component, this edge is extra. This forms a cycle. Let me go with a simple if condition here. If fu equals fu, then what we will do? So within the if condition, let's record this extra edge for the later removal, right? So we increment extra count first. So I'll just go with here extra u, sorry. This one we have to increment extra count, right? So I'll just go with extra count this one. Let's assign this one to u. The same thing, let's do it for the v as well. So this one, let me copy the same thing here. Let me paste it over here. Instead of extra u, let me go with a v, right? So this extra count, this one remains same. So we don't have to increment for this, right? So this is fine. And let me assign this one to v actually, yeah, instead of u. This is fine. Now, what if fu is not equivalent to the this one fv? Actually, did I write fu twice? Let me change this one to fv. So let me write else here. So within the else, what shall we do? Otherwise, we have to union the components by making one root point to the other. So this one will be parent of fu. Let me assign this one to the fu. This is fine, man. Let me come out of this one entirely. Now we have to print the number of operations or days that is required, basically, which is equivalent to the number of extra edges used to connect the components, right? So I'll just go with out dot println here. Let me pass the extra. Sorry, what did I give here? What did I give here? Out dot println. Let me pass here this one extra count actually. Yeah, this is fine. Yep. Now we are left with certain things actually. Just give me a second here. We have written till here, right? So we know that let's go with, or let's initialize the previous to 0 and index to 1. Previous will hold the previous component root that has been seen. And index equals 1 by we will be initializing. Let me tell you this. Index is not IDX will be going with. IDX keyword is nothing but the index into the extra edge arrays. Just remember this one. This is important. Let me go with previous equals 0, and let me go with index equals 1. Yeah. Now let's do one thing. We have to iterate over each node to identify the DSU roots, nothing but the component representation or the component representatives actually, the parent, right? Component parent actually. So let me go with the for loop here. Int I equals 1, I less than or equal to n, I plus plus. So within the for loop, what shall we do? Node I is a root if parent of I is equivalent to the I. So if yeah, parent of I, if it is equivalent to the I, then value if it is equivalent to the I, let me write the simple if condition again. If previous not equal to 0, then what we will do, for each component pair of components previous comma I, we will close one recorded extra edge, nothing but extra u of idx minus extra v of idx, right? And also we have to build the new edge. So this one we have do? We can just portray this in this way. So I'll just give you out.println. So let me go with extra u first. This is fine, I believe. Of index variable idx we have considered, right? So we need space here. This is fine. And again, let me go with extra v this time. Extra v of again we have to pass the index idx. So we have to leave space again. Let me append this time previous as well. Previous plus we need this one, what do we call, space again along with the I. Sorry, along with the I actually. This is fine. Yeah. Finally, let's increment the index idx, right? So this is fine, man. Yeah. Now let me come out of this one entirely. Let's update the previous to current component root. Nothing but let me assign previous to I. This is fine, man. Let me come out of this one entirely. Now let's flush the output. I'll just go with out dot flush here. Out dot flush. This is fine. Yeah. Um, this is fine, I believe. Somewhere I have done something wrong, man. What mistake I have done, I don't know. Index. This is fine. Previous equals I. This is also fine. Hmm. Dot println. This is also fine. What mistake I have done? God only knows. So somewhere I have misplaced the brackets where I'm not getting. This is fine. Let's debug this one later, man. Yeah. Let's do one thing before. This is it for the this one code actually easy one, right? So let's do one thing before checking the code with the different input outputs. This one inputs basically are the examples. Let me copy paste the signature starter template. So I'll just come here. Let me paste this one, right? So this is fine. Uh, we come here. Let me copy this one. The output that we need to get here is 0. So let me run this one. We have to get the error. Yeah. Error cannot find the symbol U. Also, error cannot find the symbol V. Where it is? Line number 41 and 42. We have and U and V, right? So just give me a second here. Have not given int here. So that is the reason this is screaming. Initialize which is of the type int actually. Yep. This is fine. Yep. Now let me run this one. This error has to be gone. Error variable I is already defined in the method main. Okay. Line number 56, where it is? Mm, this one. Mm, we are going with a for loop here, right? So for int I equals 1, I less than or equal to n, I plus plus, this is fine. It is saying variable I is already defined in the main method. Where we have defined man. I we have using it. This is fine, man. Same thing we are doing here, right? What's the mistake here? This is fine. What's the mistake I'm not getting here? Just give me a second here. So two things I have done wrong here. One is we have to assign parent of f of u to f of v actually, not f of u, right? So this one also I had written f of u equals f of u itself at that point of time while writing the code. So this is a typo. This is fine. And also the bracket man, bracket I knew it. It's something misplaced the brackets actually. Just give me a second here. So this one let me paste it over here, right? This one. This is fine. Now if I run this, this has to work. Yeah, we are getting the output 0, which is absolutely correct, right? So let me copy this one. We have to get the output 1 followed by 3137. Let's check the same. 1 followed by 3137. So we are getting the desired output, right? So this is fine. Let me copy the code now. Let me hit the submit button here. Let's wait for some time, man. Yeah. Let me paste the code within the this one. What do we call? Submission window. So this is fine. Let's wait for some time. running on test one. Hope this works for all the test cases, man. Let's see. Code is simple one. We have just purely made use of the disjoint set union here, the find operation basically, right? Find method. Sorry. Yeah. This has to work actually. Let's see. This is pure DSU, man. Disjoint set union with a path compression actually. For some time. Yeah, in the toast it is showing accepted, right? So the verdict that we got here is accepted, meaning whatever the code that we have written works absolutely correct for all the test cases, right? So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.